Okay, so we are going to work on the fifth and final section of 1, which is solving systems of linear equations with 3 variables. 2 learning targets that you can use equations in 3 variables to model real-life situations, as well as actually solve those equations in 3 variables and 3 equations. Okay, there are a handful of different types of solutions, just kind of like the previous ones that we've had. Okay, the first being that you can get exactly one solution. That's when you're going to have 3 planes all intersecting each other at one nice, neat, ordered pair. Okay, and this is going to happen when you're doing your work. You get x is equal to some number, y is equal to some number, and z is equal to some number. Okay, so as you're thinking about your planes kind of out there floating in space, you want to think about how they can intersect. So they can intersect at just like one nice neat spot, but they can also intersect on a line. Okay, so if they intersect on a line, okay, that's when they may be like cutting all through together all in one nice neat spot. Okay, this is going to happen when you're doing your work algebraically and you get a true statement such as 7 is equal to 7. Doesn't necessarily have to be 7, but it could be any number. Okay, the third is no solutions. So this is when your planes are going to be parallel to each other, because that means that they're not intersecting at all. So you know, if you get 3 planes and none of them intersect, well, even this one, even though this plane here is intersecting this one and this one here, they're not all intersecting at the exact same spot. And that's what we're looking for to be a solution, is intersect all 3 planes. Okay, and then again, this one here, although they all intersect at some point, they don't all intersect at the exact same point at the exact same time. So that is also a no solution situation. Algebraically, this is going to happen when you get a false statement, let's just say, such as 16 is equal to negative 16. Again, doesn't have to be 16, but it can be any number. Okay, so as we go through and we're actually trying to solve these equations here, I want to use the linear combination method, which that is going to be using elimination to go ahead and cancel variables out and actually boil it down into a problem that is going to be just like what we did in 1-1, 1-2, or 1-3. Okay, it's got essentially 5 steps to get all the way through those for somebody who needs a little bit more guidance on do this, then this, then this, then this. Okay, the first is that you want to pick a variable to eliminate. Then you'll do that in 2 equations, and then the second thing you want to do is actually eliminate the same variable using the third unused equation. Third, you'd like to use the 2 equations because you have 2 brand new equations. You're going to want to use those to solve for the 2 variables that you have remaining over, and those are going to be using the same methods as 1-1, 1-2, or 1-3. And then after that, you have 2 of your variables solved for. You got to plug it in, find the third. And then lastly, that is just simply check your work. So let's do 1. Okay, 1 is the first thing we want to do is eliminate a variable. But we want to know what variable we should eliminate. Now, really, it doesn't matter which one you pick. You can eliminate any one of them, but you want to try to pick ones that are going to be strategically easy for you. So, for example, as I'm looking through here, like let's look at 2x. 2x is the lowest value of x, so I want to ask myself whether this can be multiplied up to the opposite of 3x easily. Answer that is no. What about 5? Easily? Not really, right? This is going to involve fractions. Same here. I'm going to look at 3z. That doesn't really multiply up to negative 4z or to negative 5z. Well, what about negative 1y? This does multiply up to negative 2 easily and up to positive 3 easily. So this is the variable I want to eliminate because it's just going to require the least amount of work for me to create opposites. So I'm going to pick eliminate y. Okay, so in the first step, what I like to do is I like to put little dots off to the left of the 2 equations I'm going to pick first. Okay, so I'm going to eliminate the y's in these 2 equations here using multiplication and the elimination method taught in 1.3. So if you need a little more help with creating opposites to that, I would maybe look at going back through that video. So I want to create opposites here in the y's, so I'm going to go ahead and write these equations down and we will figure out how we do that. Okay, so I'm just copying down the first 2 equations. and I want to ask myself, what do I have to do and to what equation to create opposites in the y variable? Okay, so as I'm looking at this, I want to say, well, I know negative y, if I multiply it by 2, it's going to be negative 2y, so that's what I need to do to this bottom equation. So I'm just going to need to multiply it by 2. So I'm going to get 2 times 2x is 4x, 2 times negative y is negative 2y, 2 times 3z is 6z, and 2 times 4 is 8. And then I'm going to copy the other one just below it. Okay, so now that I have the two equations, I have scaled this equation up by multiplying it by 2, and then I've intentionally created opposites here. So what I'm going to do is, just like the elimination method in 1-3, I'm just going to add these equations together. Okay, and when I add these equations together, I'm going to get, well, 4x plus 3x is 7x. Negative 2y plus 2y, well, those are opposites. They add to 0, so they just cancel out. And then this is 10z. And then this is 19. Okay, so what I'm going to do now is I am going to highlight this. And I'm highlighting this because this is a very important equation that I'm going to use in the third step, but I'm not going to use it right now, and I actually have to kind of temporarily forget about it. So what I would like to do is just highlight that so I still have it nice and I know exactly where it's at and what equation I'm talking about, and then we're basically going to end up doing the same thing in the second step. So we're going to basically do the same thing in the second step. Okay, and what we want to do is we want to eliminate the y's again, but we have this third equation that's unused. So the second step is I want to eliminate y again. And the unused equation. Okay, so I'm going to put a little dot to the right-hand side, kind of indicating I know that this is what I'm using in the second step, but we still need another equation so I can actually eliminate the y variables. Okay, so I still need that. And, you know, again, it doesn't really matter, but you want to try to be strategic, right? So as I'm looking at this, I know that, like, again, 2 isn't going to multiply up to 3 very nicely. But what is that we already have access to is negative y will multiply up to positive 3y pretty easily. So I'm going to use this middle one again. So one thing that's important to note is that in the first two steps, you're going to use 2 equations once, but you will use one of it twice. Okay, so basically, if you're kind of using my dot method just to kind of keep track of stuff, you're going to have 2 dots on one of the equations. Okay, so I'm going to write that middle equation down here quick before I get that off screen. Okay, so now I want to do the same exact thing that I did in the first step here. I want to create opposites in the y's so that the y variables cancel out. And then I'm going to have an equation with 2 variables left over. Just a way of kind of whittling down how many variables I have to deal with. So what do I have to do to this equation here to get it to the opposite of negative 3y? Well, the first question you should ask yourself is, what is the opposite of negative 3y? And hopefully everybody here can tell me that it's positive 3y. So what does negative 1 have to be multiplied to become negative 3? Or positive 3, and that is negative 3. So I need to multiply this by negative 3. So negative 3 times 2x is negative 6x. Negative 3 times negative y is positive 3y. Negative 3 times 3z is negative 9z. Okay, and negative 3 times 4 is negative 12. Okay, and then I'm going to copy this equation down here, just right below it. And as you can see, as I'm writing the y's, I do indeed have opposites. Alright, so I have opposites, and so now I can just go ahead and add these equations here. Okay, so this is negative x. Okay, there's one more negative here than positives here. These cancel out to 0. There's 4 more negatives here, so I'm going to have negative 4z is equal to, and then this is negative 13. Okay, so then now what I want to do is I'm just going to highlight this equation as well, because we are done with the first 2 steps. Okay, so the first 2 steps are all about just boiling down two equations, so it's just x's and z's, or x's and y's, or y's and z's. You just want to eliminate one of them, and you got to make sure it's the same variable for 1 and 2. Okay, now the third step, okay, is kind of broad, but it's going to be, you just want to solve for these variables, and it's really not as complicated as it sounds. If I just write my work down here, if I look at what I have and just think about it critically, you know, this is just a problem that I did in 1-1, 1-2, or 1-3. It's two equations with two variables. So we have three different methods: graphing, elimination, and substitution. And I do not care what method you choose. You can choose whatever method you'd like. Okay? I'm going to show the elimination method, and I'll explain why here in a minute, but feel free to use whatever method you would like to use. Okay, so I'm going to solve the third step, and ultimately what's going to happen is at the end of the third step, you should have two of your variables figured out. Okay, I'm going to use the elimination method because as I'm looking at this, I think I can just multiply this by 7, and then I have opposites here, and then they just cancel out, and I'm golden. Okay, so let's do that. So this is negative 7x minus 28z is equal to, and I don't really know what negative 13 times 7 is, so feel free, times 7, so negative 91. Okay, and then 7x plus 10z is equal to 19. Okay, as you can see, I do have opposites here, so I can go ahead and cancel those out because I'm adding, and opposites add to 0, and so then I get negative 18z is equal to, and I believe that's negative 72. Let's just double check, you know. One thing I'll tell you is that these problems can be, I mean, already it's the most amount of work we've had in one problem. We haven't even got a variable yet. So it's really, really good to like pay attention to what you're doing, because, and just double checking and checking some of your mental math stuff, because if I mess something up in step 1, the whole thing is obviously going to be wrong because you screwed up earlier in the thing. So just go ahead and make sure you're taking your time on these. Okay, and then this is z is equal to, and that is 4. Okay, so now that I have what z is equal to, I can just take one of these two equations here, or one of the highlighted equations, and I can just plug it in. So I'm just going to continue my work right up over here. So I'm going to say that 7x plus 10 times, well, z is 4, is equal to 19. So this means 7x plus 40 is 19. Subtract 40. 7x is equal to negative 21. Divide by 7. Okay, and then x is equal to negative 3. Okay, so as I said, when you're done with 3, you should have your variables, the two variables you have left over, so not including the one that was isolated. Okay, so now I'm ready for the fourth step. Okay, the fourth step is going to be solve for third and variable. I'm just going to abbreviate that. We're going to solve for the third variable. Okay, so I already know that at this point x is negative 3 and z is 4. Okay, so I just got to take any of these equations and plug it in. So I'm just going to pick the top one. All the numbers are positive. Relatively, they're small, so it's really not too much extra work. So I'm going to go ahead and do that. So 3 times, well, x is negative 3, so I'm going to replace x with negative 3. And then plus 2y plus 4 times, this is 4. And then that's equal to 11. Okay, so this is negative 9 plus 2y plus 16. Equal to 11. Well, negative 9 and 16, those combine. Okay, you can just add them. Otherwise, you can say, well, I'm pretty sure there is 7 more positives here than there are negatives here. So I should get a 7 but negative 9 plus 16 is 7. Okay. But again, if you're not particularly good, if you're not particularly like solid with some of that mental math stuff, calculator, just use it. It's fine. Accuracy obviously is preferred in this class. Okay, and then subtract 7. And so then y is 2. Okay. So I'm like pretty confident here, just based on my work. We've been very tedious. We've been taking our time. That my answer is x is negative 3, y is 2, and z is 4. Okay, I do want you to check your work. I think it's just healthy practice. But again, the calculator is going to do all the work. So my fifth is just check work. And I'm going to say with the calculator, okay? Just go ahead and use the calculator. I'm going to walk you through how to do that as well. It does all the heavy lifting, and it really doesn't take that much time. So if you're taking a test and you really want that 100%, you know, this is, I mean, you know, if you, at the end of this problem, you should be able to know whether you got it right or wrong, is what I'm trying to say. And so that's up to you to make the decision of whether you want to be that accurate or not. Okay, so I'm going to put my calculator right over here. Hopefully I can just put it in a spot where it's a little more well lit. Okay. And then I can just go ahead and plug in my work. So here, the first equation is 3 times x, which is negative 3, plus 2 times y, which is 2, plus 4 times 4, which is z. Okay, when I hit enter, I should get 11. Okay, so what does that mean? That means this order triple I have written down here is a solution to the first one. But it's not a solution to the system unless it's a solution to everything. So I have to do the same thing for the second and the third. So 2 times negative 3, because negative 3 is x, minus 2, because y is 2, plus 3 times z, or 4. And when I hit enter, I should get 4. I do. So then I have to do the next one. 5 times negative 3, x, minus 3 times 2, which is y, plus 5 times 4, which is z. Hit enter, and I should get negative 1. Okay. So I went ahead, I checked my work. All 3 check out for all 3 the same order triple. Again, we can just do it on the calculator. It requires way less work. Okay, and so what does that mean? That means this is my solution. Okay, so let's just go ahead and backtrack one little itty bit and just try to decide what kind of solution do I have. Okay. So did I end up with all my variables canceling out and getting a false statement? No, so it's not a no solution. Did all my variables cancel out and I end up with a true statement? No, so it's not infinitely many solutions. Did I get a value for x, a value for y, and a value for z? Yes, exactly one solution. So this is just a one solution problem. Okay, so what I think is best for you to do right now is you all pause the video and move on to letter A, which is on the next page. Go ahead and try that one on your own, and then start the video back up to see how you did. Okay, so what I went ahead and did is I actually went and did the first 2 steps just so, one for the sake of time, and then also because the problem with these is that everybody's problems are going to probably look different. It depends on which 2 equations you start with, which variable you pick, and all this stuff is going to change from person to person. So if your first 2 steps don't look the same as mine, don't get overwhelmed. Just kind of look at one process. Is process consistent? And then also what you really want to look at is, like, are your variable values that you're getting the same? Because if they are, then obviously the work that you're doing is fine. Okay, but I will walk you through what I did here. So I decided to eliminate the y's, okay? And I decided to look at the elimination of y's, and I just see negative y. That just sticks out like a sore thumb to me, because I know that I can multiply this by 4 to create an opposite here. And then I can multiply this by negative 2 to create an opposite here. Okay, now, honestly, x would have been a fantastic choice also, because if you multiply this by negative 3, you get negative 6. And if you multiply this by negative 2, or positive 2, you get 4, which are the opposites here. So really, x or y both would have been fantastic choices. I would have maybe strayed away from z, because then you would have had to multiply both of the equations at the same time, but by different numbers. But it just goes into, you can do these kind of however you want. You just kind of have to be consistent with your work. So I picked y's. And so I took the first two equations, as you can see here, because I put my two little dots there just to kind of notate to me that that's what I'm doing. So I wrote the first equation down, and then I wrote the second equation down. Okay, after I wrote the first two equations down, I went ahead and said I'm going to multiply by 4. So 2 times 4 is 8, negative y times 4 is negative 4y, 6z times 4 is 24z, 4 times negative 4 is negative 16. And then I just copied this one down as is. Okay, I have opposites here, so I went ahead and added to get 14x, cancel, 19z, negative 23. Highlighted, because I'm going to come back to that. All right, then, number 2. I picked, as you can see here, the top and the bottom one. Okay, so as you can see, it's not the same as the previous one where we use the middle one twice. It depends. And so then here, I picked the top equation here, 2x minus y plus 6z is equal to negative 4. Negative 4x minus 2y plus 5z is 9. And I multiply by negative 2 because that will create opposites here. Negative 1y times negative 2 is positive 2y, and those are my opposites. So negative 2 times 2x is negative 4x. Negative 2 times negative y is positive 2y. Negative 2 times 6z is negative 12z. Negative 2 times negative 4 is positive 8. Then I just took this equation and I copied it down below. Okay, I recognized I had opposites, so I went ahead and added. Negative 4x plus negative 4x is negative 8x. These cancel to 0. These add to negative 7. These add to 17. So then I went ahead and took my two highlighted equations and I wrote them here. I accidentally wrote this as y, so I tried to change it to a z, but this is a z here. Okay, so now I'm looking at this one here, step 3, because step 3 probably is the most work. But it is just the same as one of those previous examples. Okay, so as I'm looking at this, I just have to ask myself, like, what do I have to do to solve for x and y? Well, I can use graphing, elimination, substitution, and it doesn't really matter. Okay, looking at this, like if I tried to solve for x, I would end up dividing by 8, end up with some fractions, end up dividing by 7, end up with fractions. You know, to me, substitution probably isn't the best method because you're going to end up with all this fractional work that can be avoided. Not that it's wrong or can't be done. It can be done, but just in my experience, you probably want to avoid that. So I'm going to use elimination. Okay, so I already see I have a positive number and a negative number, and these, you know, it's just out front. I'm going to try to create opposites in the x's. So to do that, I'm going to multiply this first one by 8. Okay, and then I'm going to multiply the second one by 14. So what happens when I do this is this should create opposites here, okay? And then also what will be really nice is that, you know, we're going to deal with mostly whole numbers. So I need to figure out what 8 times 14 is. So 14 times 8. So 112. So this is 112x. 8 times 19. 152. And that's a z. And then negative 32 times, or 23 times 8 is a negative 184. Okay. So then here I'm going to do the same thing. So 14 times negative 8. Well, obviously that's going to be negative 112x. And this is why both of these got to be positive, is because one was positive and one was negative already. So when I multiply, they're going to naturally end up one positive, one negative. So then 14 times negative 7, negative 98. Z, and then 17 times 14, 238. Okay, so let's go ahead and add. Okay, I'm adding here, and I got opposites, so those cancel, and then I go 152 plus negative 98, it's 54. 54z, and then negative 184 plus 238 is 54. Okay, and then divide by 54. get z is equal to 1. Which, as I look at what I did for work here earlier, is consistent, which is great. Okay, so then the next thing I want to do is I want to find x, because this variable, or this equation's boiled down to x's and z's already. So let's just go ahead and take the, I guess the top one. We're going to go 14x plus 19 times z. Well, z is 1. And this is equal to negative 23. So this is 14x plus 19 is equal to negative 23. And I want to subtract 19. So negative 23 minus 19 is negative 42. Didn't realize I was off the screen. Sorry, folks. So this is what I have here. So negative 42. Give you a second to look at it in case you're copying it down. Then I'm going to divide by 14. Negative 3. Okay. Now, one thing to keep in mind when you're doing these problems, okay, your work, very likely, if you went and did this completely on your own, there's a reasonable chance that your work does not look the same as me. But what should be the same is, if you're doing the process correctly, is your variable values should be the same. So you should be getting x is negative 3 and z is 1. Okay, let's move on to the fourth step. Fourth step is just actually solving for the last variable, which for us is going to be y. So I already know that x is equal to negative 3 and z is equal to 1. Okay, and kind of looking over them, I'm thinking really they're all kind of the same. That doesn't matter. Let's just pick the middle one, I guess. And then I'm going to go 6 times negative 3 plus 4y minus 5 times 1. And that will be equal to negative 7. So this is negative 18 plus 4y minus 5 is equal to negative 7. Okay, negative 18 minus 5. Let's just double check that here. I really don't want to make any mistakes, so I'm just going to be careful. Alrighty, which is negative 23. So this is 4y minus 23 is equal to negative 7 and 23. I believe this is 16, but okay, I'm really sure it's 16, but let's double check. Okay, and then divide by 4. Okay, so what does that mean? That means I'm really confident that I have an ordered triple, negative 3, 4, 1. Okay, and then we just need to check on the calculator. Okay, let's go ahead and do that. 2 times negative 3 minus 4 plus 6 times 1, negative 4. Perfect. Okay, next one, 6 times negative 3 plus 4 times 4 minus 5 times 1, negative 7. Okay, next one, negative 4 times negative 3 minus 2 times 4 plus 5 times 1. 9. Okay, so what does that mean? That means this is a solution to each of these equations, which it means this is indeed my solution to the whole system of equations, and that I have one solution. Okay, so now we're just going to kind of see what it looks like to get some special solutions. Okay, so I mean, you may have already guessed on these ones, we're probably going to get some answers that are no solutions or infinitely many solutions. So let's just dive into this. Let's just use the same process here. So I'm looking at these, and I think on these top two here, you know, I'm going to be able to get a variable canceled out pretty easily, right? I think if I just like multiply this by -3, like my x's will cancel out. So let's just go ahead and eliminate x. Okay, and so I got x plus y plus z. That's going to be equal to 2. And then 3x plus 3y plus 3z is equal to 14. Okay, so to create opposites in my x's, I need to multiply everything by -3, because then I'll have -3x and +3x, and those will cancel out. So let's go ahead and do that. So this is me distributing -3 to everything. -3 times x is -3x, -3 times y is -3y, -3 times z is -3z, -3 times 2 is -6. And then I'm just going to copy the one below it down. Alright, so let's go ahead and add, because I have opposites. Well, I have opposites here, they cancel out. I also have opposites here, and they cancel out. And I also have opposites here, and they cancel out. So what do they all cancel out to? They all cancel out to 0. And then -6 and 14, that's going to cancel or add up to 8. So this is exactly kind of what I was talking about. These problems take a significant less time if, you know, you're picking in a certain order, I guess. But this is just a false statement, okay? Since this is a false statement, what this means is it means that these two lines or planes are parallel to each other. They're never going to intersect. Okay, so they're never going to intersect. That's false, so this is no solutions. Okay, that's about it. Okay, so let's pick the next one. Okay. So the next one here, I can kind of do the same thing. You know, if we pick, I'm just looking, trying to create opposites here. Well, actually, look at the z's, right? We have z here and -z here. Those are already opposites. And actually, same thing here. So let's just pick the first two again. And let's eliminate z's. Now this particular one's going to be extra nice because they're already opposites, so there's really no multiplication needed. And you may have already noticed this. Okay, so I actually accidentally wrote this one on top and this one on bottom, but that really shouldn't matter. Okay, so anyway, we already have opposites, so we can just kind of, you know, add them together. We're going to get 2x plus 2y is equal to 8 because these cancel. Perfect. Alrighty, so I'm going to highlight that, as is our process. Okay. Alright, let's go ahead and do the second one. So I know I'm going to have to use this bottom equation. So 3x plus 3y plus z is going to be equal to 12. Well, if I look here, these again are already opposites here. So let's go ahead and minus c is equal to 4. Okay, so I already have opposites here, so I can go ahead and add. So here those cancel, and I'm going to get, because I'm adding, I'm going to get 4x plus 4y is equal to 16. Okay, so let's highlight that. All right, so then we can move on to the next step, which is we're going to use the two highlighted equations. So 2x plus 2y is equal to 8, and 4x plus 4y is equal to 16. Okay, I don't want to create, let's say, opposites in the x's. So I'm going to multiply by -2. So I'm going to get negative 4x minus 4y is equal to negative 16. And here we're going to get 4x plus 4y is equal to positive 16. And I just want to add, these cancel, they're opposites, right? Okay. So these cancel, they're also opposites, these are 0. And, well, these cancel out to 0 as well, right? 16 negative 16, that's 0. Okay, so here is what we would call a true statement. Okay, it's a true statement. 0 is equal to 0. Okay, and so what does this mean? Is that it means that at some point we're either having intersection of planes on a line, or literally the lines are overlapping each other. They're the same line. Okay, looking at this one here, these are the same line, and the planes aren't the same equation. So this tells me that this is intersecting at a line. But either way, this is just informing me that we have infinitely many solutions. Okay, so I mean that's just kind of a way to kind of diagnose what you're having. Is like this is having intersection. These lines are the same, so you know these. When I get to this third step and I have two of the same, that means they're crossing at a line. So there's infinitely many solutions here, because this statement here is true. Okay, good time now to pause the video and go ahead and try the next example on your own. Unpause the video when you are done with that. Okay, so I'm assuming that we've already paused the video and you're ready to check your work. Okay, again, with these problems, you got to be careful. Not necessarily are we going to have the exact same work look, okay, but that is, or our work is not necessarily going to look the same, but we should be able to come to the same solution here. Okay, so we got to pick a variable to eliminate. And I'm going to eliminate the y's. Okay, I'm eliminating the y's, and really you could pick z's or x's. Any variable here is a fantastic choice. But I actually see there's the y's here in the first two are already opposites exactly. So I am just going to use those two to start, because then I'm not even going to have to multiply. I can just add them. So I'm going to get x minus y plus z is equal to 4. And then 3x plus y minus 2z is equal to negative 2. Okay, and again, I already talked about we have opposites already, so there's no multiplication to be done, so we can actually just cancel these out completely. X plus 3x is 4x. Z plus negative 2z is negative z. 4 plus negative 2 is 2. Okay, sweet. Done with that. Alrighty, we can go ahead and move on to the second step. I'm going to eliminate the y's again. I have to use this bottom equation. Okay, so that means I'm going to have 2x minus 2y plus 2z, 5. And I'm going to use the middle equation here because this is a positive y. Just have to multiply it by 2. As opposed to this one, you could also use it, be fine, but you'd have to multiply by negative 2. Differences are pretty minor there, so it doesn't really matter. So anyway, let's write that one down. 3x plus y minus 2z is equal to negative 2. Okay, and this problem I need to multiply by 2. Okay, if I multiply by 2, I'm going to create opposites 2y and negative 2y. So here I get 6x plus 2y minus 4z is equal to negative 4. Okay, and then this one here, I'm going to get 2x minus 2y plus 2z is equal to 5. Okay, so I can go ahead and add these now. I do have opposites, so these are going to cancel. And then I'm going to get 8x minus 2z is equal to 1. 8x, okay, perfect. So we're doing good. All right, and so then now I need to go ahead and check and see if I can solve for the next ones. Okay, so I'm going to take the two highlighted equations I have. 4x minus z is equal to 2, and 8x minus 2z is equal to 1. Okay, looks like if I want to create opposites in the x's, I just have to multiply the top one by negative 2. Okay, so I'm going to get negative 8x plus 2z is equal to negative 4. And then the next equation here is going to be 8x minus 2z is equal to 1. Okay, I add. I did create opposites in the x's here, and I get 0. Here I also got opposites by chance here, and I also get 0, so that's 0. And then this is negative 3. Okay, so here we have a point where we've kind of boiled these down into lines. These lines don't intersect at all. We come up with a false statement. So this informs me that we are going to have no solutions. Okay. And depending on what that variable and what equations you picked, this no solutions might just pop up in random different spots. So just be consistent and treat every problem as that it's one solution and that you just want to work your way through. All right, last problem. This problem number 4 in the 1-5 notes. It's a word problem. We'll just have one of these in the notes, and then we'll let you cut you loose, I guess, to the homework. And what we have here is we have an amphitheater here, which charges $75 for each seat in section A, so in this lower arc here. $55 for each in section B, and then $30 just for a lawn seat. Okay, there are 3 times as many seats in section B as there are in section A. And the revenue from getting all 2,300 seats is $870,000. And I want to know how many seats are in section. Okay, so if I want to know how many seats are in each section, that kind of tells me that I can set up variables saying seats in A, seats in B, and seats in lawn, because the variables are going to help us answer the question. Let's just go say x is going to be equal to, we'll say this is the seats in section A. Okay. Seats in section B, and then we'll let z be seats in the lawn. Okay. So again, as all the word problems we've dealt with, you really just want to set up your variables. Your variables are going to help you write equations. Not only that, they're going to help you identify what your solution means in the end. Okay, so let's just take part by part. Let's start by saying there's a statement here in the middle. It says there are 3 times as many seats in section B as there are in A. So that means if I take my seats in section B, well, what's representing that? Y. If I take my seats in section B, Y, I know it's equal to the amount in section A times 3. So that would just be 3x. Okay, so this particular one, it just has a two-parter, 2 variables. Y, seats in section B, is the same as 3 times the amount of what's in section A. There we are. There's the first one. Okay, and then the other one, it tells us how much money. There's like a money equation going on, right? So 75 per seat in A, 55 in B, and 30 in the lawn. So we can write that. Okay, so if I want to figure out how much money I made off of seats in section A, I'm going to take $75 and I'm going to multiply it by the seats in section A. Then if I want to figure out how much money for section B, I'm going to take 55 and I'm going to multiply it by the amount of seats in section B, which is Y. And then for totals, I would add this up. But this is just accounting for section A and section B. I need to account for that lawn, right? So if I want to account for the lawn, we're going to do the same thing, which is $30 for each seat in the lawn. So plus 30z, and that's going to be equal to, what is that going to be equal to? It looks like it's going to be equal to $870,000. Okay. Well, there's another bit of information here that's a little less obvious, right? It says revenue from selling all 2,300 seats. So that means there's 2,300 seats altogether. I know this because it says so in the problem. But how am I going to represent that? Well, I know if I take all my seats in A and I add to it all my seats in B and add to it all my seats in 3 together, or not in 3 or C, I mean the lawn, add all those seats together, it's 23,000. So that means if I take all my seats in A, all my seats in B, and all my seats in the lawn, that together is going to be 23,000 seats. Okay. So then there's my system of equations in 3 variables. So let's think. Now, here's an interesting one. We have yet to come across a problem that has an equation that's missing a variable in entirety, right? Y is missing, or this first equation is missing Z. Z's not there at all. So when you have an equation that's missing a variable, okay, it's actually really, really convenient because actually it kind of eliminates either step 1 or step 2 for us because that equation's already has a variable eliminated. So what we can do is we can take the other 2 equations and we can eliminate the variable that's already missing. So what variable are we going to eliminate in these 2 equations? Hopefully you're telling yourself right now that we should eliminate Z because Z is gone from this equation, and so it's going to help us actually skip over a step. It actually makes the problem a little bit easier. So let's go ahead and start this off. Let's eliminate Z. Okay, and so I'm going to use these 2 here. Okay, and so then I'm going to have 75x plus 55y plus 30z is equal to 870,000. And then I'm going to have x plus y plus z. It's going to be 23,000. Okay, so what do I have to do to create opposites of my z's? Hopefully you're all telling me already in your own minds, telepathically or whatever it may be, that you need to multiply this bottom equation by a negative 30. Okay, that will create opposites. I'll have positive 30z here and negative 30z there. So I'm going to have negative 30x minus 30y minus 30z is equal to, and we need to go 23,000 times negative 30, negative 690,000. Okay, and then the top equation I'm just going to write right below it. Okay, so all I'm doing is just a little bit of copying. Okay, so this is great. So what we can go ahead and do is we can just start adding them together. Okay, now I know that these are going to cancel out to 0. Okay, and I believe this is 45z, right? There's going to be 45 more positives than there are negatives in that 30. Let's double check. Negative 30 plus 75 is 45. Okay, so this is 45x plus, okay, well, we can do the same thing. Negative 30 plus 55 is 25. 25y is equal to, and then negative 690,000 plus 870,000. That is 180,000. Okay. So normally our thing would be, hey, eliminate z in the other equation. Well, guess what? That is already done for us, so I just get to write that first equation down as is. I don't have to do one thing to it. So here's our 2 equations. So like I said, as you can see here, is if you see an equation with a variable missing, you can go ahead and just eliminate that variable in the other 2 equations. It literally skips an entire step for us, which is just absolutely fantastic. Okay, let's move on to the third step here. Third step is, I'm going to write my system of equations here. All right. Is equal to 180,000. All right, so what I can do here is I can pick whatever method I want. Let's think about what method is best set up. In all the previous problems, we ended up doing elimination because those problems were set up easier for us to use the elimination method. Well, this one is actually quite easily set up for us to use substitution, so I'm going to use substitution. Why is it set up for us to use substitution is the best question to ask, though. So as you're thinking about that, hopefully you're telling yourself, well, the y is already isolated, so I can take what y is equal to and replace it in the other equation. So 45x is 25 times 3x is equal to 180,000. Okay, and so 45x plus 75x, because 3 times 25 is 75. Alrighty. And let's go 45 plus 75. 120. So this is 120. X is equal to 180,000. And then I just need to divide by 120. Which is 1,500. So that means x is 1,500. We will talk about what that means at the end of the problem when we're breaking it down. Okay, so now I just want to figure out if x is 1,500, what's y? Well, I can go ahead and plug it into this one. So I'm going to say y is equal to 3 times 1,500. So y is equal to, well, 3 times 1,500. It's 4,500. Okay, now we can move on to the fourth step. Okay, fourth step, we already know that x is 1,500, y is 4,500. Okay, we just have to actually figure out z. So you can take any of these equations here. Which one's going to be the easiest, do you think? Well, I think this one, there's less multiplication altogether. I think this one's going to be the easiest by quite a significant amount, although you could use either of these two to find z. So we're going to go 1,500 here, plus, and then y is 4,500. Z is unknown at this point. Okay, so 1,500 plus 4,500. 6,000. Then we're going to subtract 6,000. So this is 2,300, or 23,000 minus 6,000, which is 17,000. Okay, so obviously we can go ahead and check our work. For the sake of time, I'm just going to go ahead and tell us that those all work. So we have 1,500, 4,500, 17,000. These are ordered triple. And as I want for any word problem that you do, I want a little breakdown of what that means. There is, well, what is x? X is 1,500, but it also represents the seats in section A. So that means we have 1,500 seats in section A, comma, well, y is 4,500, and 4,500 represents seats in section B. So there's 4,500 seats in section B, and Z is 17,000 seats in, and Z is the lawn. Okay, and that altogether is this problem. Otherwise, now's a fantastic time to move on to your homework, and I will actually see you at the beginning of the next chapter, which will be inequalities and absolute value, I believe.